Okay, we're going to talk about similar polygons and what makes them similar. First of all, you should have your notes open and in Notability. So if you look at the first part, it says polygons with the same shape. So they have to have the same shape. You have to be comparing a rectangle to a rectangle or triangle to a triangle. You can't do this if you're trying to compare a polygon in the shape of a triangle to a octagon. Won't work. They have to have the same shape. So they're identical as far as having the same shape, but they're different because of the size. You will have one that's smaller than the other one. So you have to have two different sizes. The other thing is that for them to be similar, the corresponding angles, our corresponding angles have to be, the corresponding angles have to be congruent. And the corresponding sides have to be proportional. So even if we have the same shape and they're different sizes, if the angles aren't congruent and the corresponding sides are not proportional, then they are not similar. So you have to get a match on all of those. All right. The ratio, which we talked about yesterday, of the corresponding sides is the scale factor. That's called the scale factor. And we will be working with scale factor in this unit and in the upcoming unit on transformations. If polygons are similar, then their perimeters. Their perimeters will also be similar with the scale factor, with the set, and we can find the scale factor for that. All right, so let's look at your example where we're going to compare triangle ABC to triangle DEF. Remember when we talked about triangles, we said we could kind of line them up like this, so D to E to F. So angle A has to go match or correspond with angle D. B should be congruent with E, and C should be congruent with F. So I have my two triangles, A, B, C, and over here I have D, E, and F. A matches D, B is going to correspond with E, and C is congruent with F. And then we have our sides. So A to E is 8, and E to D is 12, and then we have 10, 15, and 21, and 14. Now, they say, what is the scale factor of ABC to DEF? All right, order matters. And remember we talked about on ratio, what comes first goes on top. They're telling us now that ABC comes first, so we're going to put the ABC side on top of the DEF side. So I can do AB over DE. And AB is 8, and D to E is 12. So I have 8 over 12, and now I just need to simplify that. Both of those are divisible by 4. So my scale factor is 2 over 3. Now that should work for each side. And if it doesn't, then we have a problem. And they're not similar. But if I do 10 over 15, well, that comes out to be 2 over 3. And 14 over 21 will also come out to be 2 over 3. So these two triangles are similar. The small triangle, ABC, is 2/3 the size of our larger triangle, DEF. Now we can also turn it around and go the other way. Now we're going to compare DE at triangle DEF to triangle ABC. So now we're going to go from a larger triangle to a smaller triangle. So now we would just simply do DE, which is 12, over AB, which is 8. So now our scale factor is 12 over 8, simplified, gives us 3 over 2. So that scale factors is 3 over 2. If we did it as a decimal or a mixed number, it'd be 1.5 or 1.5. So our large triangle is 1.5 times as large as our small triangle. So that's how we write that. All right, now let's look at writing similarity statements. The symbol for similarity is just a wavy line. That's your symbol. So if I want to write a similarity statement for the two triangles we just looked at, I would write that triangle ABC is similar to triangle DEF. It's just like when we wrote a congruency statement, but we replaced that congruency symbol with a wavy line, just one, and that's our similarity statement. And we would read it as triangle ABC is similar to triangle DEF. All right, let's look at example 1. We want to list the congruent angles and write a proportion that relates the corresponding sides. So I have triangle JKL and triangle PMN. Now I'm not going to really mark the triangles right now. I just want you to look at this. Remember, if I write this as PMN, then J to P, those two angles have to be congruent. So I would have to say that angle J is congruent to angle P. That angle K is congruent to angle M. And angle L is congruent to angle N. Now let's match our sides. JK has to match with PM. They have to be proportional. So I would do that JK is similar to PM, making sure that I put my line segment over there to note so that people know I'm talking about a side. Then KL would match with MN. KL is similar to MN. And then for our last one, we do the first letter and the last letter. JL is similar to LN. And there we have our congruent angles and our proportional sides. Okay, that's your example for number 1. All right, you'll be able to do another one on your own. Okay. Don't get confused with number 2, and here's why we like to list the angles, because if you look at number 2, and it looks like that, it's going to get confusing to you trying to match the sides. So you either have to redraw it as 2 separate triangles, or just do what I just showed you. I'm sorry, that's an X, can't read, X, Y, Z, and R, Y, S. So X goes with R, Y goes with Y, and Z goes with S. Makes it much easier to do. Once you've done that, then you can go back and actually put your marks on them. All right, now we're going to look at example 4. I have a small parallelogram. That side is 42. Have a larger parallelogram. This side is X. And the problem tells me that there's a scale factor of 2 to 3. So, to solve my equation, I'm going to do 42 over X is equal to 2 over 3. Notice that this is the smaller triangle, and I'm going from smaller to larger. So my 2 goes on top, and we talked about that also, because when it says 2 to 3, remember, what comes first goes on top. So now I can just solve it. 2x is equal to 3 times 42, which is 126. Now, if I divide by 2, x is equal to 63. And we've solved our equation. And we've answered the problem. We've answered the question. It's just because all they did was say find x. All right. Now, let's look at one like number 6. We have A, B, C. A to B is X, B to C is 28, and it is similar over here to D, E, F. 25 and 20. All right, again, I'm going to label them underneath each other, D, E, F. Okay, so that means that side AB has to match with side DE. So here's AB. Actually, I have some colored markers. Let me grab them. AB matches with DE. I got a nice pink. So B to C matches with E to F. Again, it's nice to be able to color code these. And let's call this triangle 1 and triangle 2. So we're going to compare triangle 1 to triangle 2. So in our first example, sorry about this glare, I'm trying to work around it. We can look at, we're going to put 1 on top, so we're going to do triangle 1 over triangle 2. So if I compare the blue sides, I'm going to have x over 25. Now let's compare our pink sides, and remember we're putting the first triangle on top of the second. So on the first triangle, B to C is 28, and that's going to go over our 20. All right, so now we're just going to work our equation. 20x, 20 times x, is equal to 25 times 28. And I need to get my math out to do this because I don't have it. So I hope you have your calculator open. So 25 times 28 is 700. Divide by 20. So 700 divided by 20. And x is 35. So that missing side has a length of 35. All right, let's look now at one where we're going to have to set up and use distributive property, and that's number 8. All right, on number 8, we have triangle AGM, triangle KXD. A to G has a length of 32. K to X is X plus 3. Notice I'm not going to write my triangle down. I'm just going to compare those. All right. I know that AG has to go and be proportional to KX. So I'm going to have 32 over X plus 3. Now, the other side that we're going to deal with is G to M. G to M. And that has to match with X to D. G to M is 36. X to D is X plus 6. Remember, and we're going from the 36, so that's going to give me is equal to 36 over X plus 6. Remember that I told you yesterday that when you have two things down below, you have to use parentheses. It's not optional. They're mandatory. Otherwise, you're going to end up with the wrong answer, and you don't want that. All right, so I'm going to go ahead and put my X plus 3, put my parentheses. That way, I'll remember to use my distributive property. So if I cross this way, I'm going to get 32 times X plus 6 is equal to 36 times X plus 3. Now, use your distributive property. Let me get this cursor out of the way. And we get 32X plus, and then you want to do your 6 times your 32. So 6 times 32. And we're going to get 192. Oops, I forgot my X. Plus 192 is equal to 36X plus 3 times 36, which will be 108. All right, so I'm going to subtract my 32x's. So now I have 192 equals 4x plus 108. So we're getting there. We need to unhook that 108 from behind that 4. So let's unhitch it by subtracting. Minus 108, minus 108. So we get 4x. And when we do 192 minus 108, we end up with, whoops, that's a really poor equal sign, 84. So 84 is equal to 4x divided by 4, and 21 is equal to x. So that missing side length there is, so now we found x. If we actually needed to find the length of xd, I would do that by doing xd is equal to x plus 6, and I would insert that 21, and I would say 21 plus 6, so xd is equal to 27. I know it didn't ask that. I know it didn't ask that on the problem. It just said find x. But remember, it's not always finding x that gives us our answer. We have to make sure that after we found x, that we actually answered the question. So the length of side xd would be 27. Okay? What would be the length of the other side? Well, it would be 21 plus 3, or 24. So kx, if I had to find kx, kx would have a length of 24. Okay, that's your notes on similar polygons. Remember, we can be talking about a quadrilateral, we could be talking about a triangle, we could be talking about hexagons or octagons. They just have to have the same shape different sizes, but the angles have to be congruent, and all of the sides must be proportional, meaning that when you compare them, you should always get the same scale factor.